Okay, so we're looking to integrate this rational function, and we will end up using partial fractions, but before we do that, we notice we have a numerator here that is degree 4, and the denominator is only degree 3. So the first thing that we're going to start by doing is long division. So in order to do long division, we will need to expand this denominator, and we can do that. We have x minus 1 squared. So if I rewrite it, x minus 1 times x minus 1 times x plus 1, we can actually put these two together, and that's going to give us a difference of squares. We have x squared minus 1 multiplied by x minus 1, and then if we put and multiply both of those together, we end up with x to the power of 3. We have minus x squared, we have minus x, and we have plus 1. So now that we know what our denominator looks like as a polynomial, we can set up our long division over here off to the side. Okay, that's going to be divided by our cubic. So the first thing we do, ask ourselves, how many times does x to the power of 3 go into x to the power of 4? And we get x. So now we take x, we multiply it down onto this polynomial, and that's going to give us x to the power of 4 minus x to the power of 3 minus x squared plus x. We take all of this, we subtract it, and we're going to end up with x to the 4 minus x to the 4 is 0, minus 2x squared plus, we have minus 2x squared plus x squared is going to give us minus x squared. We also have this x to the power of 3 term that we cannot forget about. So that's going to actually just become x to the power of 3. And then we have 4x minus x, that's going to become 3x. So we check the degree, this is still degree 3. It's the same degree as the denominator, so we can do long division one more time. This time we ask ourselves, how many times does x to the power of 3 go into x to the power of 3? And of course we just get 1. So take that, multiply it down, see what we get. We end up with x to the power of 3 minus x squared minus x plus 1. Subtract all of that again, and we get x to the 3 minus x to the 3 is 0, minus x squared plus x squared is 0. 3x plus x is going to be 4x, and then we have 1 minus 1 is going to be 0, and that 1 is coming from here. We bring that down, so we get plus 0. Now, that means that this 4x, this is going to be our remainder, and so our integral is going to be the integral of x plus 1, which is what we had divided out, and then we have the 4x remainder, so that's going to be plus 4x divided by our cubic, but let's factor our cubic because the next step here is going to be to integrate using partial fraction decomposition. Okay, so we know we can integrate this first part. This is no issue. We have 1/2 x squared plus the antiderivative of 1, which is just going to be x. So this is really now what we're focused on. Okay, and we can write that as its own integral off to the side. We have integral 4x divided by x minus 1 squared, x plus 1. And now we want to set up what our partial fractions decomposition is going to look like. In the denominator, we have this linear term which is repeated twice, and so it's going to be case 2. And if you count up the number of terms in the denominator, we have this one is repeated twice, and so this one is repeated once. We have a total of 3 terms. We will end up with a total of 3 fractions. So it's going to be the first 2 fractions, 1 divided by x minus 1, 1 divided by x minus 1 squared, and the last one divided by x plus 1. We have a, we have b, and we have c. So really, what we're doing now is we're going to solve for a, b, and c. And we remember that we have those 2 methods from before. And we're going to start by multiplying both sides here by that denominator. So let's make a bit of room here for ourselves. If I take this and bring it over to the other side, what I end up getting, multiplication by x minus 1 squared, x plus 1. Let's clean that up a bit, and let's give ourselves a bit more room. So on the left-hand side, we have just 4x. And on the right-hand side, we're going to take each one of these 3 terms and we're going to multiply it out. In the first one, we have this x minus 1 here will cancel with one of the x minus 1s that's being multiplied in, leaving us with a single x minus 1 multiplied by x plus 1. So we have a times x plus 1 times x minus 1. We do the same thing with b. So we take this term, multiply it out, except now this x minus 1 squared term will cancel completely with the x minus 1 squared term, and that's going to leave us with just b multiplied by x plus 1. Let's look at c. So this term, we have the x plus 1 will cancel out entirely, and that's going to leave us with x minus 1 squared. So we have c times x minus 1 squared. And now we know, remembering back to the 2 methods that we have, once we have it written like this, we can start to plug in some nice values of x. And in particular, we can look at the different zeros of these terms. We have x equal to positive 1, x equal to minus 1. So let's start off with x equal to positive 1. If x is equal to positive 1, the left-hand side becomes 4. And on the right-hand side, we'll notice that this term is going to become 0, and so is this term here. And that's going to leave us with only the b term. So we have 4 is equal to b multiplied by 2, which is perfect because now we get that b is equal to 2. Let's fix that up a bit. B is equal to 2. Let's do the same thing with x equal to maybe negative 1. And if x is equal to negative 1, the left-hand side becomes minus 4. You'll notice on the right-hand side, this term is still 0, as is this term. So now we can solve for c. So we have c multiplied by negative 2 squared. So we end up with negative 4 equal to 4c, which means that c is going to be minus 1. And now we have 2 of the 3 unknowns. We still need to solve for a. However, you'll notice that we have run out of nice values of x to use. So at this point, you could go and use the second method. The second method, again, being to expand this right-hand side, collect like terms, and then equate coefficients. But we can use a little bit of ingenuity at this point to realize that these 2 sides, the 2 sides of this equation, are still going to be equal to each other for every value of x. And so there are many other values of x to choose from, especially now that we already know what b is and what c is. So for example, let's give ourselves a bit more room. if I let x be something nice, let's say let x be 0, the left-hand side now becomes 0. The right-hand side, none of these terms here are going to disappear entirely, but I can still plug in x equal to 0, and I'll get a multiplied by 1 multiplied by minus 1 plus b multiplied by 1 plus c multiplied by 1, minus 1 squared. And we know that b is positive 2, and c is minus 1. So really what we get is that a is equal to positive 1. And now we have all three, a, b, and c. We can go back and now look to integrate our decomposition. Okay, so we have our a value, b value, and c value. Going back to our integral, we know how to do our decomposition for this. So this whole thing now is just going to become equal to 1/2 x squared plus x, plus we're now going to have three separate integrals. So a is 1 divided by x minus 1. We go to the second one, we have b, which is 2, divided by x minus 1 squared. And we go to the third one, we have minus 1. Let's not forget our dx from here. We have minus 1 over x plus 1 dx. And so each of these now should be fairly straightforward to integrate. This first one and the last one here, those are just going to be, both of them, logarithms. Those are the same sort of thing we saw in case 1. And this one right here is just going to require a simple substitution. So let's take a look. We end up with 1/2 x squared plus x plus ln absolute value x minus 1, plus we do our substitution here. We can do u equal to x minus 1 for that, which is going to work out very nicely because du will just be equal to dx. And so really there's not very much work to do at all. Let's take the constant outside, and this just becomes 1 over u squared du. We'll integrate that in a moment. The last one, we have minus 1 was the constant, and so it'll be minus ln x plus 1. So now we rewrite it one more time. 1/2 x squared plus x plus ln x minus 1. And we can integrate this term. We have u to the negative 2, so we increase the exponent by 1. Divide by the new exponent is going to give us negative 1 over u, and we know that u is x minus 1. So we can sub that in. And having done so, I realize we did forget one thing right here. We did forget the plus c, and so we're also going to put in the plus c now in our final answer. And that's what we get. So that is case 2 partial fractions. We were able to use just the first method to find a, b, and c, but we also had to do long division at the beginning.